Hello everyone, my name is Dr. Vile. Welcome to my YouTube channel, which is dedicated to helping you with your A-level chemistry problems. If you find this video helpful, please like, please share with your classmates, and please subscribe. The focus of this video is going to be about how do we calculate atom economy. So we need to firstly look at what atom economy is, and then how do we calculate it. And as always, it's best looked at with some examples. And I've got 4 that we're going to go through. So the first question says, calculate the atom economy for the reaction below, assuming that iron is the useful product. So when we're trying to calculate atom economy, what we're interested in is what percentage of the atoms are useful as opposed to wasted atoms. And the way that we solve this is by using the atomic masses to help us out. So you'll need a calculator and a periodic table to do this. And the formula that you need is atom economy. Excuse my terrible writing. Atom economy is equal to the molecular mass, I'll just call that MR, of the useful product divided by the MR of all the products and atom economy is measured as a percentage, so we have to times this by 100. So in our example here, the useful product is the iron, and there are 2 of them. We have to factor that into a consideration. And then we also have to allow for the Al2O3, which is the alternative product. So let me clear the screen and I will talk you through how to do the calculation. Okay, so iron is the useful product, and if you look it up on your periodic table, which you should have to hand, I think that will be helpful for you, you'll see that its atomic mass is 55.8. And because there's 2 of them, we have to times it by 2. And then what we're going to do is divide by the atomic mass of all the elements. So that's going to be your 2 times 55.8 for the iron. And then you've got 2 lots of aluminium, which is 2 lots of 27. And 3 lots of oxygen, which is 3 times 16. Times this by 100. Let me just grab my calculator. And I get that to the nearest whole number, that is 52%. Let's have a look at another problem. Here you've got the reaction of sodium hydrogen carbonate producing sodium carbonate and carbon dioxide and water. So the useful product is this one, the Na2CO3. So you work out the molecular mass of the compound Na2CO3. So sodium is 23, so you've got 23 plus 23 because there's 2 of them, plus carbon, which is 12, and 3 lots of oxygen, which is 48 in total, 3 lots of 16. And then you divide that by the molecular mass of all the products. So that's your 23 plus your 23 plus your 12 plus the 48. Carbon dioxide comes out as 44. And water is 18.02. And then you times this all by 100, because remember atom economy is a percentage. And to the nearest whole number, I get that to be 63%. This one here is a little bit more complicated because it involves brackets, but the principle is the same. This is your useful product, the aluminium sulfate, and then the waste product are the free lots of the hydrogen. So to solve this, you've got 2 lots of aluminium, so that's 2 lots of 27, so that's 54 from the aluminium. And then you've got sulfur, which is 32.1, but there's 3 of them. So that's 96.3. And then for the oxygen, you've got 4 oxygens, but you're timesing it by 3, so that's 12 oxygens. So that's 12 times 16, which is 192. So that's your useful product. And then we divide it by the useful product plus the 3 lots of the hydrogens. That's 54 plus 96.3 plus the 192 plus, well, that would be 6.06. Each hydrogen is 1.01 and there's 6 of them in total. So that's 342.3 divided by 348.36 and then times by 100 because it's percentage. Which to the nearest whole number comes out as 98%. And here, this is straight off an exam paper. You had to balance the equation and then calculate the atom economy for the formation of phosphoric acid. Now, phosphoric acid is this one here, H3PO4. So firstly, we need to balance the equation. Otherwise, we're not going to be able to calculate the atom economy. The best place to start is you've got 5 chlorines here and only 1 here, so we times this by 5. If you don't know what you're doing with regards to balancing equations, I have made a separate video on that on the channel, so please check that out. That gives you 8 hydrogens in total on the right hand side and only 2 here, so you need 4 lots of H2Os. That conveniently balanced the oxygen. We've now got 4 oxygens, so in total we've got 1 phosphorus, 8 hydrogens, 5 chlorines and 4 oxygens, so that is now balanced. And what we have to now do is calculate the atom economy. So we need to work out what H3PO4 is. So firstly, you've got 3 lots of hydrogens, so that's 3 times 1.01 plus the phosphorus. And I wish I'd got my periodic table to hand here because I can't actually remember phosphorus off the top of my head. Let me just very quickly look it up. Phosphorus is 31.0 to 3 significant figures. And then you've got 4 oxygens here, which is 4 times 16, which is 64. So that's your phosphoric acid. And then you're going to divide it by whatever that is, plus the 5 HCl's. So you'd have the 3.03. You'd have the 31. You've got the 64. And then HCl. Now HCl is 35.5 and 1.01. So that's 36.51. Times 5, and be careful with brackets here. And then we times this by 100. So grab your calculator So it's going to be 98.03 as the top, divided by 280.58. So we then plug that all into the calculator, so 98.03 divided by 280.58 times by 100, and to the nearest whole number that comes out as 35%. So just to recap, if you're asked to calculate the atom economy, very common question, not normally worth a lot of marks, but will be worth 1 or 2 marks on a Unit 1 paper for WJC. You calculate the molecular mass of the useful product and you divide it by the molecular mass of all the products, then times it by 100 to calculate the atom economy. Well, I hope that was helpful. If it was helpful, please like this video, please share it with friends, please subscribe to the YouTube channel, and I'll see you next time.